Now, in this question, we have this Lewis structure right here, and we have this carbon right here that's going to be highlighted, and we want to know three things about this carbon right here. First thing we're going to know is how many sigma bonds it has, and the second thing we want to know is how many pi bonds it has, and the third thing that we want to know is what is the orbital hybridization that's going to be around this carbon right here. Now, to figure out the number of sigma bonds it has, you need to know that a sigma bond, that's going to be equal to the same thing as the number of hybrids. So a sigma bond and a hybrid, those are pretty much the same thing. And the number of sigma bonds and the number of hybrids is also going to be the same thing as the number of domains that are going to be around this carbon right here. And so if we can count the number of domains that are going to be around this carbon right here, we can figure out how many sigma bonds it has, which also is going to be how many hybrids it is. And so if we know that a domain, what that is, it's going to be the number of bonds, or it can be the number of lone pairs. And for the bonds, it can either be a single, double, or a triple. Those are all going to count as one domain. And so what we're going to do is we're going to count the number of domains that are around this carbon right here. And we have one bond right here. That means that's going to be a sigma bond there. And then we have a bond right here. That's going to be a sigma bond there. And now we have this double bond. That's going to be one domain. And so that's going to tell us that one of these bonds in here is going to be a sigma. And so this right here, if you want to make this one the sigma, then this one right here will be the pi. And so we have 1, 2, 3 sigma bonds. And we have no lone pairs. So the number of sigma bonds that we have is going to be 3. And so we have 3 sigma bonds in there. And now we got to figure out the pi bonds. Now for the pi bonds, what you want to do is you want to find the double bond, or you want to find a triple bond. Now we don't have any triple bonds, but we do have this double bond right here. And so because this bond here we said was going to be the sigma, it means that this bond right here would have to be the pi. And so what a pi is, it's basically going to be a p orbital that's going to go above and below the sigma bond, because the sigma bond, the hybrid, is going to be going to go straight across from this carbon to this oxygen right here. And so that's going to be the sigma bond. And to make a double bond, we have to go above and below this, because this is going to be in 3 dimensions. It's not going to be a 2-dimensional bond like this. And so that means that we have 1 pi bond. And so we have 3 sigma bonds and then this 1 pi bond right there. And now what we need to do is we need to figure out how many orbital hybridizations that are going to be around in here. Now to figure out the number of hybrids, what you can do is you can look at the number of domains or the number of sigma bonds. And so because I have 1, 2, 3 different domains, I have 3 domains. That means I'm going to have 3 hybrids. And so the first shape that I can have is going to be an S. And so I'm going to have an S, and it's going to hybridize with a P. And I need to have an SP hybridized. And so those are going to be 3 different hybridizations that are going to occur. And so for the P, it can go in the X, Y, and Z axis, and the S can only go in one axis. So I need just one S to hybridize with 2 P's. So I'm going to put an SP2 right here. And so this would be an SP2 hybridization. If I had 4 domains, let's just for example say that I had 4 domains, that would be an SP3. I need 1 S and 3 P's to get 4 domains. But because I have these 3 hybrids right here, that means I need to have this SP2 hybridization. And so these are going to be the answers for this question.